Okay, today we are going to continue Chapter 4. We're going to move on to Section 2. As I mentioned the other day, in Section 2, it's all about what we call the slope of a line. But before we get into that, I just want to review what we have discussed so far in terms of the forms of a linear equation. So far, we've talked about standard form. Now you recall with standard form, we had ax plus by equaling c, where a, b, and c were numbers, and x and y were variables, okay? And when we had an equation in standard form, since we had two variables, we need 2 points. Remember, we can find the x-intercept, and the way we can find the x-intercept is by taking c divided by a, comma 0. And then we can also find the y-intercept. And to find the y-intercept, we would have to do 0, comma, now c divided by b. We graphed those 2 points. Because we need 2 points because we have the two variables, then you would connect the dots and form your slanted line. We said that whenever you have two variables, you will always form some type of slanted diagonal line. And then I'm going to leave a space here for a moment, all right, because we will come back and fill in some information about standard form. Then we looked at vertical lines. We talked about vertical lines, lines that are going to go straight up and down. They have a different equation. X, the variable, is going to equal some number, I just call it a, all right? And whenever we have an equation like x equals a and we graph it, you will always form a vertical line that goes up and down. And since we only have one variable, all we need is 1 point, okay? We don't have to worry about anything other than just graphing that one value of a on the x-axis, okay? I'm going to leave a space here, all right, because we will fill in some information, other information about vertical lines. Then we also talked about the other day horizontal lines. Horizontal lines that move left to right. Now, horizontal lines take a different form of y equals the variable, some number, I say b, okay? And once again, since we only have the one variable y, once again, all we need is 1 point, all right? And once again, I'm going to leave some space here, and we're going to fill in some information about horizontal lines in a little bit. Okay, so that's what we've talked about so far in terms of graphing linear equations. Now let's talk about that new concept, okay, in section 4.2, the concept of the slope of a line. Now, when we talk about the slope of a line, all right, we're talking about how we are going to move from one point to the next. So slope provides movement. It provides direction. Okay? We use a particular letter, one letter in particular, whenever we are talking about the slope of a line to represent it, and that would be the variable m. Why m? Because we are talking about the movement from one point to the next, okay? How do we get from one location, from one coordinate to the next? We need some type of directions. We need how to move, and that's what the slope provides for us. Some people refer to it as the rise over the run. When we talk about the rise, we're going to move up or down along the y-axis. If the number that's in the rise is positive, then you're going to move up. If the rise happens to be a negative number, then you are going to move down along the y-axis. When it comes to the run, if the run is a positive number, you're going to move to the right along the x-axis. If the run tends to be a negative number, then you are going to move to the left. Okay? And let's just take a look at some examples. For example, if we have a slope of, let's say, 2/3, okay, because your slope should be expressed as a fraction. Now here, if we were going to talk about directions on how we are going to move, since the rise is a positive 2, we're going to have to move up 2. And since the run is a positive 3, we're going to have to move to the right 3 units. So these are the directions that we will have to move according to our slope, okay? Because as I said before, the slope provides directions, how we move from one coordinate to the next coordinate, from one point to the next point, okay? Let's try another example. Let's say we have a slope of maybe -4. Now, slopes should be expressed as a fraction. So let's think about -4 as a fraction. -4 as a fraction is the same thing as -4 over 1. So now we can clearly see what is the rise and what is the run. And now let's just talk about how we're going to move. The movement in terms of this particular slope. Well, since we have a -4 as the rise, that means we have to move down 4 units along the y-axis. The run is a positive 1, which means we're going to have to move to the right 1 unit. Okay, so this is the direction of movement from one coordinate, from one point to the next coordinate. Okay, so you do want to pay close attention to the slope as it provides direction. If you go the wrong direction, just like when you're driving a car, you get lost. Okay, you're going in the wrong way. All right, slope, you have to follow the directions very carefully in terms of how you move. Okay. Do be careful if you see a negative fraction. Many times, a negative fraction might be written like this. Negative, let's say, 1/5. Okay? Be careful here. When you see a negative sign written in front of the fraction like this, means we could make the negative on the 1 and the 5 would remain positive. That would be correct. Or what other students may do is they make the 1 positive and the 5 negative. All three of these numbers are equivalent, okay? Whether you write a negative 1/5 or a -1 over 5 or 1 over a -5, they all mean the same thing. And that's why I can put an equal sign in between them, because they are equivalent fractions, okay? Do be careful. Many times when students see a -1/5, they make both the 1 and the 5 negative, and that is incorrect, okay? Because we know these numbers, these first three numbers, if we were to type them into our calculator, we would get a negative decimal. Okay, we would get a -0.2. But if you take a -1 and divide it by a -5, we know that a negative divided by a negative would be a positive 0.2. And we are looking for a negative solution. So be careful. If you see the negative in front of the fraction, do not make both the numerator and the denominator negative. You can make the numerator or the denominator negative, but not both, okay? All right. Another formula for slope. Okay, so the slope is the rise over the run. Okay, that's one way people think of it. And this is the direction in terms of how we move. Now, the formula that we use to calculate the slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. This represents the difference of y's, or the change in y, over the change in x, or the difference of x. Okay? Now, we use this formula, okay, if we are given two ordered pairs. If we are given 2 points on the line, and those 2 points would be x1, y1, and x sub 2, y sub 2. Oops. If we are given 2 points on the line, we can figure out the slope of that line. Okay, we can figure out how we can move from one point to the next. All right, and I want to spend some time talking about this formula here. Okay, slope is a very fundamental algebra concept. It is extremely important, okay, because it's going to lay down the foundation of future math classes like calculus. All right, in calculus, you use slope extensively. All right, so it's very important that you understand slope, as it will help you with your future math classes. Now, let's do some examples, first of all, where we're going to find the slope given 2 points. Okay, so we want to find the slope, and let's say we are given 2 points of 2, -1 and 5, 3. Here are the 2 points that we have on the line. And if it helps us, we can actually draw these points. This way it's a visual aid for us. Sometimes people are visual learners, and there's nothing wrong with that. Okay? And if we can see certain things, they may help us to understand them. So let's graph these 2 points. We first of all have a point at 2, -1. That would be here. Our second point would be at 5, 3. Let's see where that would be. That would be here. So now what we have is this line. Okay? And we are trying to come up with the slope. I am trying to figure out what are my directions if I'm going to move from this first point to this second point, because 2, -1 represents my x1, my y1, and the 5, 3 represents my x sub 2, y sub 2. And if I use my formula, recall the formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, let's see. Let's plug in my numbers. Y sub 2, that has a numerical value of 3, minus y sub 1, that has a numerical value of -1. X sub 2 has the value of 5, minus x sub 1 has a value of 2. So now let's simplify as much as we can. 3 minus the -1 would be 4. 5 minus the 2 in the denominator would be 3. So we have a slope of a positive 4/3, which means from a direction point of view, we would have to go up 4 and to the right 3. And let's just see if we're going to do that. Okay, I'm starting here at 2, -1. And if I want to get to this second point, I'd have to follow my directions. I would have to go up 4, 1, 2, 3. Let's see. 1, 2. Oh, I drew my point in the wrong spot. My apologies. 2, -1 is here. And 5, 3. Let's see. That's 3, 4, 5, 1, 2, 3. Okay. So here we have this line. My line was slightly off. I apologize for that. Okay. And so now I want to go from 2, -1 to 5, 3. And I'm going to use my directions of the slope. I'd have to go up 4 units. 1, 2, 3, 4. But then I have to move to the right 3 units. 1, 2, 3. And sure enough, I land on that second point. Okay, so we went up 4 and we went to the right 3 units. And that's how we get this particular point. We follow the slope. Okay, it provides movement, direction for us. Okay, what do we notice about the slope and its relationship to the line? Well, the slope happens to be a positive number. It's greater than 0. And if the slope is a positive number like this, we can see here that the line increases from left to right. And that will always be true whenever you have a positive slope. If your slope is positive, like it is here, 4/3, the line should always increase as we read the graph from left to right, as it is doing here. Let's try another one. Once again, we are asked to find the slope. And we'll do a different set of ordered pairs. Hopefully I'll graph them correctly this time. Sorry about that. -1, 2, and let's say 1, -3. I'm going to start by graphing my ordered pairs on my coordinate plane. So -1, 2 would be here. 1, -3 would be here. When I go to connect my dots, I am trying to come up with the slope of this line. All right, I want to know what is my movement from the first point of -1, 2. How can I get to the second point of 1, -3? I need some type of directions. So once again, our formula M, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, where -1, 2 is my x1, y1 coordinate, and 1, -3 is my x sub 2, y sub 2 coordinate. So I'm going to now plug those numbers in. Y sub 2, that's -3, minus y sub 1, that's the number 2. X sub 2 has the numerical value of 1, minus x sub 1 has the numerical value of -1. Simplifying what we can, -3 minus 2 is a -5. 1 minus the -1 is a positive 2. So now we have a slope of -5 over 2. In terms of movement and direction, I would have to go down 5, and I'd have to move to the right 2. And let's see if that in fact is true. To get to this next point, I'm going to start here at -1, 2. And I have to go down 5 units. 1, 2, 3, 4, 5. But I also have to move to the right 2 units. 1, 2 units. So I went down 5 and to the right 2. And I went from the initial point to the second point. okay? Because I followed the directions. I followed the movement. I used the slope. Now, let's take a look here. Earlier we said if the slope is positive, the line increases from left to right. But now we noticed that we have a slope that is in fact negative. Okay, it's a negative 5/2. And what is that overall effect on the line? But now when we have a negative slope, we see that the line decreases from left to right. And once again, that will always be true whenever you have a negative slope. Okay? If the slope is positive, your line will increase. If your slope is negative, your line will decrease. Okay? So keep that in the back of your mind. Let's try another one. Once again, we want to find the slope. And now let's say our ordered pairs are -2, 5, and now 4, 5. Why don't you try that one? Okay, pause the video at this point, see how you make out, find the slope, okay, and when you're done, turn it back on and we'll take a look at it together. Well, once again, to find the slope, we use our formula, and then we're going to plug in our numbers. So let's do that. Y sub 2 is 5, minus y sub 1 is 5. X sub 2 is the number 4, minus x sub 1 is a -2. When we simplify, we get 0 over 6. And 0 divided by 6 is 0. Okay? 0 divided by any number is 0. So now we don't have a positive slope. We don't have a negative slope. We have this slope of 0. Well, if we were to graph this, would the line be increasing? Would the line be decreasing? Well, let's take a look at the graphs of these 2 points and see what we can say about the line. Well, -2, 5 would be here. 4, 5 would be here. And if I connect my dots, my line is not increasing, nor is it decreasing. It's staying flat. It's staying horizontal. And that is true, okay, about all horizontal lines. All horizontal lines have a slope of 0. So recall earlier when I said leave a space, or that I was going to leave a space when it came to horizontal lines. Because now I'm going to fill something in about the slope. Because not only do all horizontal lines have a slope, or should I say have an equation of y equals b, their slope is always going to be 0. Okay, so that will always be true. So that's another piece of information about horizontal lines. Okay, not only does it always have the form of y equals b, but your slope will always be 0. Okay? Let's see what else we can figure out. Let's try one more, a little bit different. Okay? Once again, you're going to be asked to find the slope. And here now, let's say we have the ordered pairs, 3, -1, and 3, 2. We want to find the slope, m. I start with y sub 2, which is 2, minus y sub 1, the -1. Then we have to do x sub 2, the 3, minus the x sub 1, 3. When we simplify here in the numerator, 2 minus the negative 1, that's 3. 3 minus 3 would give us a 0 in the denominator. Now, a 0 in the denominator is mathematically undefined. You cannot divide by 0. It's impossible. You can divide into 0, as we saw in the previous problem. 0 divided by any number is 0. But a number divided by 0 is mathematically undefined. You could even try doing it on your calculator. You will get some type of error message, okay? So here we have a slope that is undefined. Well, what does that mean in terms of the line? Is it going to be slanted? Is it going to be horizontal? Okay, well, let's take a look. Let's actually go and graph these 2 points and see what we form in terms of the line. Let's start with the ordered pair 3, negative 1. That would be here. Next, let's plot the ordered pair of 3, 2. And when we connect these dots, we don't form a diagonal slanted line. We don't form a horizontal line. Instead, of course, we form a vertical line. And we can see now here that whenever we have a vertical line, all vertical lines will have a slope that is undefined. So once again, let's go back up to the top where we left a space about vertical lines, okay, and let's fill in the information that we now have. Because what is true when we talk about vertical lines is that their slope will always be undefined. Just like the slope of all horizontal lines will be 0, the slope of all vertical lines we say is undefined. Okay? Very important piece of information. All right? You'll notice that I left a space here as well, okay, when we talked about standard form, because what if I have an equation in standard form? We want to be able to figure out the slope. So I'm going to give you a formula for the slope of an equation in standard form. Here's what you have to do to find the slope of an equation in standard form. You take the opposite of A and you're going to divide it by B. So that is another piece of information about standard form, that we can get the slope of a line in standard form. Once again, how do we do that? We take the opposite, which means you have to change the sign of A, and you're going to just divide that number by B. Okay? Let's look at an example. So for that, I have to go all the way down. Taking a lot of notes today. So let's say we are given the equation of maybe 2x plus 5y equals 7. This is an equation in standard form. I want to find the slope. Well, remember, okay, standard form is ax plus by equals c. And if I want to find the slope of this line, okay, according to my formula, the slope is the opposite of A divided by B. Well, A is 2, but I need the opposite of A, so that would give us a negative 2. Over B is the number 5. So we would have a slope of a negative 2/5 for this equation. If we were to graph this, you would see that you would have a slope of a negative 2/5. Okay, so that's another piece of information about standard form. Okay. Now, let's say you were given an ordered pair of maybe negative 2, 3, and let's say you are also given a slope of maybe negative 1/2. We want to graph this. We can do that, okay? We would start by plotting our ordered pair. We always need a starting point, and luckily for us, we have one. We are given a coordinate of negative 2, 3. So let's graph that. Negative 2, 3 would be about here. Okay, that would be the location of our starting point. Now, since we have a slope, we have direction. We know how we can move. I have to go down 1 because the 1 is negative, and I have to move to the right 2 units. Okay, so let's do that. I'm going to start here, and I'm going to go down 1, but then I have to move to the right 2. And then I'm going to put another dot. If I want to continue in that fashion, I can go down another 1, and then I would have to move 2 more to the right and put another dot. I could keep going. I would go down another 1, and to the right another 2, and put another dot. All that is really needed is 2 dots. You don't have to get carried away like I sometimes do. 2 dots is more than enough to plot your points. And then, of course, we always connect our dots, and you will see that you should form a straight line. Okay? And that's because we graphed the initial point. This is our starting point. And then the slope gives us direction. Okay? And that leads us to our last topic in this particular section. Now, standard form is not the only form of a diagonal line. Okay? It's a good form, but it's probably not the one that most people are familiar with. Most people are familiar with what we call slope-intercept form. Okay? Slope-intercept form is going to look a little bit different than standard form. Slope-intercept form looks something like this. Y equals mx plus b, where m is the slope. But we also have another piece of information in the problem, and that is 0, comma b. And that is your y-intercept. Those are the two pieces of information that you get from a line when it's in slope-intercept form. You need both in order to graph, okay? When it was in standard form, we figured out 2 points, and we graphed those 2 points, and that's how we were able to graph that equation. But here, when we have an equation in slope-intercept form, you're going to have your y-intercept. That is your starting point. That's where you're going to begin your graph. And then you're going to move using the slope. For example, let's say we have y equals 1/3 x plus 5. We want to graph this. We want to be able to identify the 2 very important pieces of information. What are those pieces of information? We need the slope, as well as we need the y-intercept of 0b. Well, the slope m is the number that's in front of the x. It's the coefficient. So if I look here at my equation, the number that's in front of the x is the 1/3. So there's my slope. That's how I'm going to move. I'm going to have to go up 1, and I will have to move to the right 3. But we need a starting point. We need a y-intercept of 0, b. Well, b is the number that occurs after the variable. So 0, the number after the variable is the number 5. So this is my starting point. That's where I'm going to begin my graph. So let's actually go to a coordinate plane. I begin with my y-intercept at 0, 5. So here's the origin, 0, 0, and I have to go to the point of 0, 5. 1, 2, 3, 4, 5. So this is the location of 0, 5. That's where I'm going to begin my graph. But now I need another point. According to my slope, I'm going to go up 1, and I have to move 3 to the right. So if I go up 1 and 3 to the right, here's our next point. I have two variables. I need 2 points. And because I also have 2 variables, I know I should form a slanted line. And sure enough, I do. Okay? What do we notice about this line? The line is increasing from left to right. Why is that? Because the slope is positive, as we said before. Let's do another example. Okay? Let's say we have y equals 2x minus 4. Okay? Once again, this is not standard form. Standard form, remember, had the x and the y on the left side of the equation. Here we have y by itself. Okay? We still need the slope. Once again, slope-intercept form is y equals mx plus b. And the slope is the number in front of the x. And even though it's just the whole number 2, I'm going to write it as the fraction 2 over 1, which means I have to move up 2 and to the right 1 unit. But before I can do any movement, I need a y-intercept. I need 0b, which in this particular case is 0, -4, because my b value is the number that occurs after the x. Well, I have now enough information, okay? I can now start my graph. Where am I going to start my graph? At the y-intercept of 0, -4, which would be about here. Okay, that's the location of 0, -4. But then I have to move, according to my slope, up 2 and to the right 1. If I want to keep going, I can go up 2 and to the right 1. And like I said, sometimes I get carried away. I can go up another 2 and to the right 1. No matter what, you should always form a straight line. And when I connect my dots, sure enough, I do. Once again, since the slope is positive, our line increases from left to right. Okay. So a lot of stuff going on here, all right, involving this idea of the slope. Okay. Let's just recap what we talked here about today in terms of slope. We had quite a bit of formulas that allowed us to find the slope, how we defined what the slope was initially, okay? Here, slope, we said, is movement, it's direction. It's the rise over the run, okay? And we have this formula here, very important formula, that would allow us to find the slope if we are given 2 points. We also talked about how we can find the slope when it's in standard form. by taking the opposite of A divided by B. We said that all vertical lines will have a slope that is undefined. We said all horizontal lines will have a slope that is 0. And then we also talked about that alternative form, I'll put it right here, the slope-intercept form. Now with slope-intercept form, remember, it looked a little bit different. Y equals mx plus b. Okay, so it looks different from standard form. It still has two variables, x and y, okay, but with slope-intercept form, y is by itself. And if it's in slope-intercept form, we can get the slope, which is m, and we can get the y-intercept, which is 0b. Okay, so that is all the information about our linear equations. Your book, on a side note, does discuss a third form of a linear equation called point-slope form, but you don't have to worry about point-slope form. If you are familiar with it and you want to use it, you can, but many people find point-slope form confusing for whatever reason, so since we are not responsible for it, I'm not going to show it to you, all right? So we have standard form, and we have slope-intercept form of the diagonal lines. Then you have, of course, your vertical and your horizontal lines. That concludes section 4.2, okay? Do try the homework that goes along with it, see how you make out, and feel free to email me any questions you may have. Until the next time, be well.